Hi guys, welcome to this new video. So in this video, I'll be talking about merge sort, which is another implementation of divide and conquer. So in merge sort, there is an input which is an array of n elements, and what will be the output? The output will be a sorted array of n elements. So let's say I have this array, and I want this to be sorted using merge sort. So let's see what we'll do. So I have 50, 80, 20, 16, 13, 55, and 35. So these are my elements 1, 2, 3, 4, 5, 6, 7 elements I have. So this is an input. This is an input array A. So if we do merge sort on this, what we will do is like we will divide this. Essentially, this is an implementation of divide and conquer. So what we will do is like we have 50, 80, 20, 16, 13, 55, and 35. So what we will do is like we will divide this array into two parts. So when we divide, what we will get? Let's say this is A. This is my array A1 to 7. So A1, 7. So let's divide it into two parts. We will have A1 to 4 and A1 to 5. Sorry, A5 to 7. Then we will have A1 to 2. Next we have A2 to 3. Sorry, A3 to 4. Here we have A5 to 6. And here we'll have A7 to 7. So this will be our base case because both are 7, you can see. So we will return from here. So when I is equals to j, we will stop. So this will be our base case. So now we will do A1 to 1, A2 comma 2. Also this will be our base case, and this will be also our base case. A3 comma 3, A3 comma 3. This is to our base case. So this is the basic basis of merge sort. So what we did, this we divided into two parts. This is the application. This is an application of divide and conquer. We are dividing it into two parts in every step. But how it will sort? So it will sort using the merge algorithm. So at this point, I have two elements, one each. So what we'll do is merge these two. So after merging, we'll get this as a sorted one. So at last, I have 50 and 80 here. You can see 50 and 80. So it comes divide. I will get 50 and 80. So let me use another pencil. Here I have 50, here I have 80. If I merge these two, I have to write the merge algorithm, which is the basis of merge sort. So when we will merge, I will get 50 and 80 here. Here I have 20 and 16. As you can see, 20, 16. When we will merge this, I will get 16, 20. And again, this will get merged. We have to write the merge algorithm. So then I will get 16, 20, 50, 80. From this part, I will also get A55 will be there, A66. So from here, I will get 13, 55. If I merge it, I will get 13, 55. I have here 35, and after merging, I will get 13, 35, and 55. Now these two will get merged, and I will get the sorted array, which is 13, 16, 20, 35, 50, 55, 80. So this is how merge sort works. So what is this merge algorithm? Let's understand this. Because this is the basis of the merge sort. So this is where we are merging, right? And this is where I am merging. You can see these are the two sorted arrays which are getting merged. This is also sorted because here is only one element, so one element is always sorted. So this is sorted and this is sorted. So we are merging these two. So this is the merge algorithm. So the input to the merge algorithm is two sorted arrays. Let me check. Yeah. So the input to the merge algorithm will be two sorted arrays. Input will be two sorted arrays. So let's see. Let's take this example only. 10, 20, 30, 40. This is one part of my sorted subarray. Two sorted arrays oblique subarrays. This is my one sorted subarray. And this is my another part of the sorted array, which is 11, 21, 31, and 41. So how I will merge this? So you can see this part is sorted and this part is also sorted. So my goal is to merge these two sorted arrays to get a fully sorted array which includes all these elements. So I will take another array and I will take two pointers. One pointer will be at I and one pointer will be at, the one pointer will be at this element and one pointer will be at this element, starting of this element. So this is my new array of size 1, 2, 3, 4, 5, 6, 7, 8. 8. One, two, three, 4, 5, 6, 7, 8. So for this position, how many items are fighting? So for this position, this is fighting and this is fighting. So I have to get the smallest element here. So I will compare a of I with a of j. What is a of I? A of I is 10 and a of j is 11. So a of I is less than a of j. So I will put a of I here. So 10 will go here and I will increment this I to this position. J will be at same position because j is not yet in the final array, which is sorted. So again I will compare a of I with a of j. So a of I is a of I greater than a of j? Sorry, a of I is less than a of j? No, because 11 is smaller. So I will put 11 here and I will increment the value of j. J will go here. Now I will check what? A of I, A of j. Is A of I is less than A of j? What is A of I? 20? Yes, it is true. So I will put 20 here. And I will increment the value of I. I will go this here. Now again I will check A of I is less than A of j. No, because 21 is smaller. So I will put 21 here and increment the value of j to 31. Now I will again compare 31 with 30. I am seeing 30 is smaller, so 30, I will put 30 here and I will increment the value of I. So now I will compare 31 with 41. 31 is smaller, so I will put 31 here and increment the value of j. Now I will check 40 and 41 who is smaller. So 40 is smaller, I will put 40 here. Now if I increment I is out of bound because I don't have any element. So I have finished I and my j is in 41. So this is the last element. So I will put 41 here. So you can see I have merged these two sorted arrays. So what will be the time complexity of this algorithm? So the time complexity of the algorithm is like, let's see how many comparisons we did. We compared this with this with, so you can see I have compared every elements, only 41 was not compared and I put the 41 here. So plus n minus 1. M is the left sorted array, n is the right sorted array. So this is the maximum number of comparisons you will have. It will be go of m plus n minus 1. This is the worst case. And what will be the best case? Best case will be, I forgot to say one thing, like if I have arrays of two different sizes, sorted arrays, let's say you have 8 elements here, you have 11 elements or 13 elements here. So let's say you have completed this array fully and all of and some elements is remaining of the other sorted subarray. Some elements are remaining from the other sorted subarray. So what we will do, we will just put them in the sorted array because you have already finished comparing 8 items. So you have nothing to compare, but you have left with let's say X amount of items in this group. So this will be copied to this array. This is the worst case. This is the worst case. So you can see this is the number of comparisons. This is the number of comparisons. But you have also done another thing. You have moved all these elements to this array. So the number of moves is O of m plus n. So what will the time complexity? Time complexity will be this two, but like biggest of these two, maximum of these two. But these comparisons can become less, but these moves can never be less than this. So the time complexity of this merge algorithm will be O of m plus n, where m is the length of left sorted subarray and n is the length of right sorted subarray. So this will be the time complexity. And why this is the worst case and like the number of comparisons can be less than this, I will show you. So let's take this new example like this one. So this is the one sorted array, subarray, and this is another part of the sorted subarray. So I am doing this to show you like the best case for like the comparisons. So let's say your I is at this and j is at this. So when you have this array where we will store the merged one, like the final sorted subarray. So this two will compare, 10 will come here, we will increment j, 20 will come here because 20 is less than 40, 30 will come here. So sorry, j will come here and 30 will come here because 30 is smaller than 40, and this whole array will get moved. What happened? Just a minute. Yeah, so this total array will get moved here. So we did only these three comparisons. So here on the number of comparisons is like from the smallest group. So O of min of mn. This is the best case when all the items come from the same group and which is also the smaller one. Here this is one. So here it is only let's say if it is m, it is n. So the number of comparisons will be O of n because all the elements came from the same group and which also happens to be the smallest group. So but now you can see even if the number of comparisons is only 3, we have to move all the elements to this new subarray. So the time complexity to move all the elements from this to this, from this array to this array, which is the resultant array, will be O of m plus n, where m is the left subarray sorted subarray, n is the length of the right sorted subarray. So you can see this will be always the time complexity because this can vary. Here you can see it is only n. Previously it was m plus n minus 1. So this will always be m plus n. So the time complexity will be of time complexity of merge algorithm is always the moves. What do is always the moves? Just a minute. Is always the moves. What are moves? You have to move this to this element to this element, this array, this array. So all the elements have to move to this new array. So it will be t of m plus n, and here this number of comparisons will not take into account. This will be O of m plus n. This will be the time complexity will be O of m plus n. We will not take the number of comparisons into account because here it is less, but the moves will always be the same, which will be the number of elements in the left subarray plus the number of elements in the right subarray. So you can see the time complexity of merge algorithm is t of m plus n.